Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the problem solving section called the 3 Huffman decoding. And for this particular challenge, it says Huffman coding assigns variable length code word to fixed length input character based on their frequencies. More frequent characters are assigned shorter code words and less frequent characters are assigned longer code words or edges along the path to a character contains a code digit. If they are on the left side of the tree, they will be a 0, or if in the right, they will be 1. Only the leaves will contain a letter and its frequency count. All other nodes will contain a null instead of a character, and the count of the frequency of all of it and its descendant characters. For instance, consider the string abracadabra. There are a total of 11 characters in this kind of string, and this number should match the count in the ultimately determined root of the tree. Our frequencies are A, which has 5 occurrences, and then B. The next one should be B because B is placed right after A on the word abracadabra, and we have 2 occurrences of B, and then the R, which is also 2 occurrences. Also C, only 1 occurrence, and then finally D, also only 1 occurrence. The 2 smallest frequencies are for C and D, both equal to 1, so we will create a tree with them. The root node will contain the sum of the counts of its descendants. In this case, 1 plus 1 equals to 2, and the left node will be the first character encountered, C, and the right will contain D. Next, we will have 3 items with a character count of 2, the 3 that we just created, character B and the character R. The 3 came first, so it will go on the left of our new root node, and B will go on to the right. Repeat until the tree is complete, then fill in the 1 and 0s for the edges. The finished graph will look like this in a form of root, just like on the second parameter here. But all of this description is a description for the term of Huffman coding, so we will understand better if we happen to encode a word into more memory compressed variant. So but our task is to decode, which is from the function right here. Then it is just a description, and it doesn't matter of what we are trying, and it doesn't relate of what we are trying to solve here. And let's say we already have the visualized tree over here, and the input characters are only present in the leaves or internal nodes have a character value of null. We can determine that our value for characters are A is on the 0 and B is 1, 1 and 1. So how do we determine A is 0? Is by working with the parent root or the parent node, which is the root right here, which is with the denominated by the node with the number of 11. And A, since A is traversing over the 0, which is traversing to the left, and we got the A right here, and there is no left and right property of this node, and we don't have this node on the left and right property is also null, so it will stop as we traverse over the 0 and we got A, so A is equals to the 0. Let's say if we happen to traverse in order to get the letter B, so we traverse over the right side and then right side again and finally right side again until it stops, because B has no longer has the left and right node. So B is the end of the node, marking the end of the node. And as we traverse over from the root to the B, we are accessing the right, and right. So if we translate this into a binary term, and we got the B as the 1 right here, and then this one, and finally this one. So if we happen to access the D part or the C part, let me give another example of the C part. So we are accessing 1, C is equals to 1, and then next one should be 1, and next one should be 0 because we're accessing the left side, and finally we are accessing the left side, and then we got the address that we want, which is 0, and C is on the address 1100. So if we look over the C right here, oh my bad, it is supposed to be 1100, not 1110. I drew this mistakenly, so I'm sorry for this. And we are supposed to be starting from 1 1 and then 0 and then 0, so that is the correct traversal. And then the D is supposed to be 1 1 0 and then 1, and finally R is only 1 and 0, and R is addressed from the right and then going to the left. So we got the R letter, and this for the encoded string. And to avoid ambiguity, Huffman encoding is prefix free encoding technique. No code word appears as a prefix in of any other code words. To decode the encoded string, follow the 0 and 1 to a leaf and return the character tree. So from this part now on, this part is important because we are trying to decode the Huffman encoded one. So we are given the function, given the pointer to the root of the Huffman tree and the binary coded string to decode, that we need to print the decoded string, that we have the function called the decode right here, or decode huff. And if you notice, we have a void right here, void function, is because we are using a Java 7 as our language. If you want to use something else other than Java 7 or anything in Java in general, then go ahead and encourage you to do so, to explore more about a coding language. So we have the function of the decode that takes two parameters, which is the given two parameters, which is the s as a string and the type node that named as the root as the second parameter. And the function itself, it is expecting a return void, so it must return the decoded string, so we can just only print using the system.out.println. And we have the two parameters like I already described, and the input format we have given two plain string, which is the s right here, which contains the binary of the encoded Huffman string is only 1 and 0s, and the background code creates Huffman tree, then passes the head node and encoded string into the function. So for the root right here, as visualized from the sample input, so this we will be using this as our reference as we traverse from the string right here. So why we should traverse over our string right here? Because the string of the s right here contains the Huffman encoded variant. So let's say we have the string right here, this as represented by the string in the form of binary in the form of string, I'm sorry, it is the other way around, and then the sample output is supposed to be A, B, A, C, and A. And we are basically converting this particular string, and by given the tree right here, or the linked list or the root tree node, and we got the output right here, which is A, B, A, and C, and A. So let's say what is inside of the string s right here, we can just simply print this out using the system out println. We are working with Java, don't forget that, and we can just run our code, and we have the standard output of 1 0 0 1 0 1 1. So we can just copy this and paste this out. This is the given system out.println as the comment. And then how do we get the A, B, A, C, and then A? So watch this carefully, because I'm trying to explain this to you. So let's say we are given the binary string as 1 0 0 1 0 1 1, and then we are given the certain tree node. So how do we decode this as the word variant? So the first one that we need to consider is by the first string right here, which is 1. So we go to the 1, the first one, which is on the right, then we traverse over from the roots. So this one is called the root because this is on the topmost, and we are traversing over the right because the first string right here of the string s. Then we got 1, and then we are assigning A because A no longer has a child of the left and right, so A is the marking of the end of the node chain. So we are assigning A, and then we are resetting our iteration of the node root. We are going to traverse this using the current node as the iterator, and as we go back to the top again. Then A is already assigned, then we need to iterate over the 0 right here. We can use a for loop later on. 0, since 0 is placed on the left side, then we are traversing the 0. Then we got this node which has the another child nodes, which is 0 and 1, B and C. So we are traversing again. So this part of the node traversion is not going to be resetted, unlike on the A right here, because A is marking the end of the node. So we are starting all of it again to the root, and then using the 0 right here. I'm going to repeat this again. Using the 0 again, we are starting from the root to the node 2 right here, mark as the 2, and then 0 again. We are going to the left, and left right here, which is B. Then B is going to be assigned, and it will be stopped, and we are starting all of it again from the root node. So B is going to be assigned, and we are accessing 1 right here, iterating over the string binary. Since 1 is on the right, then we are assigned another A, and A is going to be assigned, and we go back to our root node to be traversed upon. So for the next one, we have the 0, then we are assigning 0. We are traversing over the next node, which is node 2 right here, and then the next one should be 1. Then we are going to the right side of the node, which is the children of the node 2. Then we got the C. Then we are going to assign C, because C has no longer child nodes beneath the node itself. So C is going to be assigned, and we go back to our root node. And finally, we traverse to the final string binary, which is 1. And 1, you guess it, is containing the A, and we are assigning A, and we go back to our root node. So let's say the for loop already depleted, or we already traverse over the string binary right here, and this one already stopped, and it already finishes traversing, and we can just return our result of the A, B, A, and C, and A into our system out print line, because the Java code is expecting a void, so we can just printing our A, B, A, C, and A into our system out print line as the answer. Print line method. So how do we implement this? Transfer our method into the implementation right here. So we can just, for the first thing that we need to do, we have to declare a string variable called the answer string, and we can just declare an empty string as for now. And for the next one, we need to declare our for loop to iterate over the string s right here. We can just use a for loop. If you are using the JavaScript, then you can use the for let I is equal to 0 as long as I is below the s.length, and then I plus. But we are not working with JavaScript. Currently we are working with Java, so we can just transform the let into the integer I is equal to 0, and then as long as I is below the length of the string, using not the length property but with the length method. And then we can just use the system out print line to make sure if we already printing the correct part of our string as we traverse this string binary one by one, is by using the s.charAt. If you are working with the JavaScript or TypeScript, then you can just passing the s with the index of the current I. But since we are working with Java, then it's not going to be work, and we can just instead we are passing the s.charAt of the current I using the charAt method, and we can just run this to see if the for loop already work properly. And we have the output line by line, which is 1 0 0 1 0 1 1, which is the same as the first example. 0 right here, 100 1011. And for the next one we have a lot of lines going on, and for the next one we also have a lot of lines going on because the expected decoded, the expected output has a lot of words, a lot of letters going on. So let's say we already got our system out print line working correctly, our for loop iteration already validated as working correctly, so we can just store this. Instead of using system out print line as we print its character inside the for loop, we can just define our char, and then for the current string, and we can use char@, of the current I of the current for loop, current iteration. And the next one, we should consider our root node to be traverse of mount, so we can declare a node called the current node, and we can just define our root node as the head, which is on the node 5 right here as the root node. And for the next one, we need to check if it is going to the either to the right or left by determining if it's going to be of the current iteration is going to be 1 or 0. We can check if the current string is equals to the either 1 or 0. In JavaScript, you might want to use 1. It's going to be right, going to right. If it is 0, it's going to be going to the left. So in Java, we cannot simply implement like this because it is incompatible operand types of char and string. So this left operand is a char because of the declared char right here, and the right operand is in the form of string. So we need to convert both into a char or both as a string. So I'm going to use this part of the 1 as a string in order to check if it is hitting the string 1 or is going to the right of the current iteration. I'm going to convert this as a character using the .charAt method, and we are passing the current index of 0, and then we can use the system out.println to check if it's hitting the number 1 of the current iteration, going to system out println and passing the right. And let's run our code to check, and we have right, but currently we don't know that we are going either to the right or left, so we can just print in the system out to println, print the current string to check if it is on the left or right. Oops, using the system out println, not just print. And if we hitting 1, then it is going to be printed as right. If it is 0, then it's not going to print right at all. So we off to a good start right here. The same thing also applies to the test case 1. If it's 1, then it's going to be print right. So how do we implement this, integrate this into our root traversal? So it is fairly simple. We can just define our current node right here assigned to the either right or left. If you notice right here, from the class node right here, we have the public int of the frequency. We have the frequency of 5 right here, and then the char, which is the character of the data, which is on the left side, which is A, B, and then C. And then we have the another chain node, which is left and right, which is the left and right nodes beneath the branches right here of the current node, is visualized as the tree node right here. On the left, we have the left node of the 2 right here, which is B, and the right node of the C right here. Of the root node, we have left node of the 2, and the right node is the A right here. So we already got the properties from the respective current node. As we iterate the current nodes, then we can simply, if the current string is 1, then we are going to the right. We are heading to the right is by using the current is equals to the current dot right. We are using the right property from the public node left and right. So that way we are accessing the current, assigning the current dot right as the current, just current property right here. And if it's the other way around, if it is 0, then we can just use the else statement right here. Else, if it is 0, then we can just assign the current to the current dot left. And finally, we need to check after all of the current checking right here, if we already either going to the right or left, checking if the next node of the next current node is null. There is no child nodes beneath the current node that we are traversing on from this current variable right here. Then if it is marking the end of the node, which is denoted by the letter A right here, letter C, and then letter B, then we can just simply add a check if the current left is equals to null, and also the current right is also equals to null. If it is, then we can just simply assign the answer string right here, build this or construct this one by one to the right using the given data from the current node. Given the data property of the current node, we can just assign the answer using the plus equals sign operator, and we can just assign the current dot data, and we have to reset our current node back to the root by using the current is equals to the root. If it is not, if it still has the child nodes, then we are not going to go through this if check, and we can just move ahead to the next iteration of the string binary, and the direction will be determined by these if checks. If it is 1, then it's going to be going to the right, and if it is 0, it's going to be to the left. And finally, we should return the answer using the system out.out.println as the answer right here. So let's run our code to see if it works, and we have a wrong answer right here because we are still printing our system out println of the current string right here. And let's run our code again to see if it really works, and we still have a wrong answer. Why is it happening? It's because we are assigning the node of the current root inside of the for loop. We have to move this above the or outside of the for loop in order to get the proper traversal between the left and right property. So it's going to be undisturbed, and if we happen to place this inside of the for loop right here, as we traverse over the string binary, the position of the current node, let's say we already on the state of the 2 right here, node 2. So as we traverse over the for loop right again, then this position will be resetted back to our root node, which is on the node 5 right here, by reinitializing the current node as the root. So this is not a best practice, so we ought to move this into outside the for loop. So let's run the code again or submit this code to see if it really works. Okay, so it seems that everything works flawlessly. So that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.